Whoa, is that like?
All right, here we go. So today we are writing equations of quadratics. All right, we're going to use the information in our graph to find the equation of the quadratic function. Now, the easiest way to do this, and it doesn't matter if they want you to write it in standard form, then you might have to go through one of the other forms to actually write the equation of the quadratic first before you can actually get to standard form. So if they give you the x-intercepts to begin with, then the factorized form might be the better route to go to actually write your quadratic function. What is, in general, the factorized form? That would be standard form.
Oh, that one.
X minus Q, X minus P, what went in the front? The A, okay? So P and Q represented your x-intercepts. A was the value that, affected how big it was, skinny it was, et cetera, et cetera. That A is the same A no matter what form you write it in. If you know the vertex, then you can always start in vertex form. What's the general form for vertex? X minus h squared plus k. What are you missing? The a in the front is the same a from the x-intercept form, the factorized form. H and k represent your vertex. That's why it's easier to go into vertex form and then FOIL, distribute, combine like terms to get to standard form. And then last but not least, if you do not know any of the information, x-intercept, vertex, then you're going to have to create a system. System of equations. How do you solve a system of equations? Substitution or elimination. Do not forget that standard form for quadratic is ax squared plus bx plus c. Okay? That will help you when it comes to the actual writing a system part. So, everybody has the worksheet 2J, right? We're going to look at a few together as a class, and then I'm going to leave you guys to do the remainder on your own. Okay? And we're going to start by looking at number 1. The directions say to write the equation of the function in standard form, and we're looking again at number 1. When you look at number 1, what information do you have? You have a vertex, which is located where? 2, 1. And then you have a y-intercept at 0, 5. Okay? So that's what we're given in number 1 in that picture. Now, since you're given the vertex, it would be easiest to do this in vertex form, which is y equals a x minus h squared plus k. Since we know the vertex, we can go ahead and plug that in. Is this going to be a minus 2 or a plus 2? It's going to be a minus 2 squared and then a plus 1. I still don't know my value of a to write my equation. But I do have a y-intercept. Plug that in for what, Garrett? And 0 for x. So I can take that 5, plug it in for y, take that 0, plug it into x, and then I can use that to help me figure out the value of a. 0 minus 2 is a negative 2. Negative 2 squared is 4. So this becomes 5 equals 4a plus 1. 4a equals 4. A equals 1. Yes, sometimes it comes out that a was just 1 to begin with. Okay? Sometimes it happens that way. So now that I have my value of a, my equation in vertex form is y equals x minus 2 squared plus 1. But it's not asking for vertex form. It's asking for standards. Nathaniel, how do I get in standard form?
With a, so y equals x squared. Oh wait, just to multiply. Y equals x squared. Well, oh, you have to complete the square.
I complete the square. Got FOIL. I gotta expand this. Okay? I'll complete the square if I'm trying to go from standard to vertex, but I need to FOIL to get from vertex is standard. So this becomes x minus 2 times x minus 2. Do not forget about that plus 1 on the outside. X squared minus 4x plus 4 plus 1. When I add the 1, it gives me the final equation of x squared minus 4x plus 5. Look at number 2. What information do we have in number 2? An x-intercept and a y-intercept, kind of like that one problem from the whole review. What are my x-intercepts? What's my y-intercept? -12? I don't have the paper. So we do something similar like how we do in number 1. But this time, instead of using the vertex form, we're going to use the factorized form.
This is like the first one.
What are my x-intercepts? It's going to be x plus 2, x minus 6. Be very careful. So think about it. If we were to solve this, we would set both of those factors equal to 0. So we have to get a -2 and a positive 6. So when you plug them into the factor form, it's the opposite. Turn it back to y. How can I find a? Plug in the y-intercept. That becomes 2 and a -6. When I multiply them together, that gives me a. So what's the value of a? 1. Again, no, they will not all be 1. So I have y equals x plus 2, x minus 6, because there's a 1 on the outside. To get in the standard form, I need to FOIL. When I FOIL that, x squared minus 4x minus 12. At as a class, last one we're going to look at is number 5. Number 5. And number 5, do we have a vertex? X-intercept? No, we have 3 random points. This one, you're going to have to use a what? A system. You're going to have to use the system. So, -4, 8, 1, 13, and 0, 4. When you write a system for these types, use standard form. I mean, we got to get there anyway, so I might as well use standard form for this. But we know our C, don't we? What's our C?
4.
It's 4. The C in standard form is always the y-intercept. So we lucked out on that one. If it was 3 points where one of them was not our y-intercept, this would be a system in 3 variables, not 2 variables.
That's all.
So there is the possibility that you may have to do a 3 variable system of equation. This particular one is a 2 variable because we know our y-intercept. If we're given another point other than our y-intercept, this one would have been a 3 variable. So we can use that and those other 2 points to plug in for x and y. Okay? So when we do that, we'll get 8 equals a times -4 squared plus b times -4 plus 4. When I simplify this, Negative 4 squared becomes, so this becomes a 16a. This next term becomes a minus 4b, and then you have the plus 4 on the end. Since this is going to end up being a system, what should I do with that plus 4 at the end? Subtract it to the other side. So then this becomes 4 equals 16a minus 4b. Could divide all of them by 4. I'm not gonna do that because I've never done it where I divided by 4. I'm pretty sure we get the same answer, but I won't. Let's do the other one. When I plug in 113, I'll get 13 equals a 1 squared plus b times 1 plus 4. When I simplify and subtract 4 to the other side, what's my other equation? A squared? 9 equals a plus b.
I'm sorry, bless you.
So now we got a good old school system of equations. If substitution was your thing, go ahead. Solve this system using substitution. If elimination was your strong point, then use elimination. Look at some of y'all faces. Raise your hand if you remember elimination and substitution. Okay, all right. Let's do this one together. I was expecting that. It's okay though. Elimination and substitution, which one?
Substitution.
All right. Substitution it is. When you're solving using substitution with these two equations, you want to solve one of these equations for one variable, and then take that expression and plug it in for that variable in the other one. Let's use this one over here on the right. What variable you want to solve for? A. To solve for A, I'm going to subtract B. So I'll get 9 equals, or A equals 9 minus B. Here's something, here's an IB type thing. They might say you get down to this point. Say the question is, write an expression for A in terms of B. Write an expression for A in terms of B. When it says in terms of a variable, that means that it should be A equals blah, 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 B. Does everybody understand that?
Can you repeat that?
Write an expression for A in terms of B is basically what we just did here. So we solved for A, basically. We rewrote A so that now it's in terms of B. I'm just making sure I'm crossing my T's and dotting my I's. So now that we have A in terms of B, we're going to substitute that in. So we'll have 4 equals 16. 9 minus B in parentheses minus 40. It's a substitution. 16 times 9 is 144 because we're going to distribute that 16. Minus a 16b. And I apologize if my b's and my 6's look similar. Old school algebra. And then once we know B, we can substitute that in and solve for A. So A equals 2. And now that we have our A, our B, and our C from way back, our final equation is y equals 2x squared plus 7x minus 4. And that is your equation for the quadratic in number 5. I apologize, plus 4.